Volumetric calculations. In this module, we will study about solution, percentage, molarity, molality, normality, mole fraction, and parts per million. An introduction.
There are two test tubes, A and B, containing copper.
The other difference that we see is that the solution in test tube A is more concentrated as compared to the solution in test tube B.
The concentration of these solutions is determined by using
Solution. Solution is a homogeneous mixture of two or more chemically non-reacting species whose composition can be varied within certain limits. A solution consists of a solvent and a solute. Solute is the component of solution present in a lesser amount.
Many of us enjoy a black coffee. It is a homogeneous mixture prepared by mixing and heating different ingredients like coffee, sugar, and water. When we mix and heat these ingredients, it is not possible to identify the ingredients present in the mixture because sugar and coffee seem to disappear. It results in formation of solution which is a homogeneous mixture. A solution is a homogeneous mixture of two or more substances whose composition can be varied within certain limits and the components cannot be seen with the naked eyes. Do you know we come across many solutions in our everyday life? Oceans, lakes, soft drinks, and soap solutions are various examples of solutions. The air we breathe is a solution of several gases, and various fluids running in our bodies are also solutions. So we can say solutions are important to us.
concentration of a solution.
A solution having lesser amount of solute is termed as a dilute solution. The solution having comparatively more amount of solute is known as If we add 1 gram sugar in a beaker A containing 250 milliliters of water and add 10, the concentration of a solution can be expressed better quantitatively. The concentration in percentage can be expressed in three ways: mass percentage, volume percentage, and mass by volume percentage.
Mass percentage is the mass of a solute in grams dissolved per 100 grams of the solution. Consider the following example. 10% by mass of sodium chloride solution means amount of sodium chloride is equal to 10 grams and the amount of solution is equal to 100 grams. Mathematically, mass percentage is expressed as follows. Mass percentage of solute is equal to mass of solute upon the sum of mass of solute and mass of solvent into 100.
Let us solve a numerical. If I dissolve 20 grams of sucrose in 200 grams of water, what will be the mass percentage of sucrose in the solution? We have mass of sucrose dissolved, which is equal to 20 grams, and the mass of solvent is equal to 200. Thus, on applying the expression and substituting the values, comes out to be 9.09. If W is equal to the mass of the solute in grams, V is equal to the volume of the solution in centimeter cube, M dash is equal to the molecular mass of the solute in grams per mole, M is equal to the molarity of the solution in moles per liter, then we have number of moles of solute is equal to the mass of the solute The expression of molarity now becomes as follows. Point to note. Equation 2 gives the relation between the molarity of the solution with the mass of the solute in grams, volume of solution in centimeter cube, and molecular mass in grams. Do you know that the formula of molarity involves volume, which depends on temperature? Relationship between volume and molarity. If V1 milliliters of a solution of molarity M1 is diluted to volume V2 milliliters and the molarity of the diluted solution is M2, then it is expressed as M1 into V1 is equal to M2 into V2. The molarity equation for reaction between the two reactants is as follows. Here, N1 is equal to the number of moles of reactant 1 and N2 is equal to the number of moles of reactant 2.
Let us solve a numerical. Calculate the molarity of the solution prepared by dissolving 12 grams of sodium. The given numerical can be solved by following the series of steps. The expression for calculating molarity is as follows. Step 2. Calculate the number of moles present in 12 grams of sodium hydroxide using the given expression. Step 3. Determine the volume of solution in liters. Here the volume of the solution is equal to 0.600 liter.
Molality.
Molality is defined as the number of moles of a solute dissolved per 1000 grams of the solvent.
If mass of solute is equal to W dash grams, molecular mass of solute is equal to M dash grams per mole. Mass of solvent is equal to W grams, which is equal to W by 1000 kilograms. Molality of the solution is equal to M mole. Let us solve a numerical. A solution of potassium. Step 1. Calculate the molecular mass of the solute, that is, potassium carbonate. This comes out. Step 2. Calculate the number of moles present in 25 grams of potassium carbonate. Step 3. Determine the mass of the solution. We are given the density of the solution as 1 gram per milliliter. And Step 4. Determine the mass of the solvent. According to the formula, the mass of solution is equal to the mass of solute plus mass of solvent. We have mass of solution, which is equal to 600 grams, and the mass of solute as 25 grams. Step 5. Determine the molality of the solution. We already have calculated the number of moles of potassium carbonate, that is 0.18 mole, and the mass of solvent as 575 grams, which is equal to 0.575 kilograms. Do you know a solution containing 1 mole of solute per 1000 grams of the solvent is known as a molar solution? Molality is considered a better term for expressing the concentration of solution as compared to the molarity. In molarity, we consider the volume of the solution that changes with the temperature due to the expansion and contraction of the liquid with the temperature. Normality.
Normality is defined as the number of gram equivalents of a solute dissolved in per liter of a solution at a particular temperature.
The equivalent mass of a solute expressed in grams is called gram equivalent. Thus, the gram equivalent of solute is equal to the mass of solute upon equivalent mass of the solute. If W grams of a solute with the equivalent mass E is present in V centimeter cube of a given solution, then the expression for normality is
Equivalent mass is the mass of a substance that combines with or displaces 1.008 parts by mass of hydrogen or 8 parts of oxygen or 35.5 parts of chlorine by mass. Given are the formulae for expressing equivalent mass. Some more formulae for expressing equivalent mass are as follows.
Let us solve a numerical. Calculate the volume of 0.2 normal acid required to neutralize 20. We are given the normality of acid is equal to 0.2 N. The normality of sodium hydroxide is equal to N by 20. The volume of sodium hydroxide. Therefore, the volume of an acid can be calculated as follows. The volume of acid required to neutralize 20 milliliters of N upon 20 of sodium hydroxide is equal to 5 milliliters. Relationship between molarity and normality can be expressed as follows. For acids, normality is equal to the product of molarity and basicity. Let us solve a numerical. Calculate the normality of a solution that is prepared by dissolving 0.36 gram of oxalic acid in water, we know that the normality is equal to the number of gram equivalent of solute upon the volume of solution in liters. For calculating normality, we will follow Step 2. Calculate the equivalent mass of the solute, that is, oxalic acid, with the help of the given expression. Step 3. Calculate the number of gram equivalents of the solute, that is, oxalic acid dissolved with a. Step 4. Calculate the volume of solution in liters. Volume of solution is equal to 200 centimeter cube. As we know, 1 liter is equal to 1000 centimeter cube. Therefore, the volume of solution in liters is equal to 0. Step 5. Calculate the normality of oxalic acid with the help of the given expression. Mole fraction.
Mole fraction is the ratio of the number of moles of a particular component to the total number of moles of all the components present in the solution.
Mathematically, mole fraction of a component is equal to the number of moles of the given component upon the total number of moles in a solution. For a binary solution of component A and component B, the mole fraction of each can be calculated as follows. The sum of mole fractions of all the components present in a solution is always equal to 1. Let us solve a numerical. Determine the mole fraction of each component in the solution containing 30% water, 30% ethanol, and 40% acetic acid by mass. We know the formula to express the mole fraction of a component, which is as follows. Now we will proceed further. Step 1. Convert the percentage mass of each component present in solution into grams. Step 2. Calculate the molecular mass of each. The molecular mass of acetic acid is equal to 60 grams per mole. The number of moles of ethanol on calculating comes out to be 0.65 mole. Similarly, the number of moles of acetic acid is also calculated. The number of moles of acetic acid on calculating comes out to be 0.66 mole. Step 5. Calculate the mole fraction of each component present in the solution using the given formula. As we know that the mole fraction of ethanol is equal to the number of moles of ethanol upon the total number of moles. Similarly, the mole fraction of acetic acid can be calculated, which is equal to the number of moles, parts per million.
Parts per million is defined as the mass of solute in grams present in 1 million, that is 10 to the power 6 grams of the solution. 7 parts per million of calcium carbonate solution means that 7 grams of calcium carbonate is present in 10 to the power 6 grams of solution. The following animation will summarize about the various concentration terms.
John is feeling very tired. So he decides to take glucose solution to get instant energy. He mixes 2 teaspoons of glucose in a glass of water and drinks it.
John, how are you feeling now?
Now I am feeling good and energetic.
Can you prepare the glucose solution of the same concentration for me, as I am also feeling low today?
Same concentration? Yes. Why not?
Son, before preparing the glucose solution of the same concentration, you must know how many grams of glucose you dissolved earlier in how many milliliters of water.
I don't know.
Solutions of the same concentration can only be prepared if we know the quantity of the solute and the solvent.
Now I understood.
Let's correlate the concept of concentration with our day-to-day life.
We use rupee in India, but when we go to America or Britain, we use dollar or pounds. These are all different forms of currencies used to express money. Similarly, concentration of a solution can also be expressed in various ways. Let us learn about them. The mass percentage of a component of a solution is defined as the amount of solute present in 100 gram of the solution. The volume percentage is defined as the amount of solute present in 100 milliliter of the solution. The mass by volume percentage is defined as the amount of solute present in 100 milliliter of the solution. Parts per million is a unit to express the concentration of trace amount of solute in a solvent. Mole fraction is the ratio of number of moles of one component to the total number of moles present in a solution. Normality is defined as the number of gram equivalents of solute present in 1 liter of solution. Molarity is defined as the number of moles of solute dissolved in 1 liter of the solution. Molality is defined as the number of moles of solute dissolved in 1 kilogram of solvent.
Now John, you have learnt about different concentration terms. Can you tell me, out of molarity and molality, which concentration term is better to express the concentration of any solution?
I don't have an idea.
The answer is very simple. Molality is a better concentration term than molarity. You know that molality is moles of solute per kilogram of solvent and molarity is moles of solute per liter of the solution. Molarity is temperature dependent, whereas molality is independent of temperature. So, when the temperature of the solution increases, volume of a solution increases, and heating makes the solution's molarity go down, but the molality remains unchanged.
That's interesting. Now, I will revise the formulas of the concentration terms.
Choose the concentration term that is independent of temperature. The options are A. Molarity, B. Molality, C. Normality, D. Weight by volume percentage. Identify the quantity that is used in normality of the solution. The options are A. Number of gram equivalents, B. Number of moles, C. Number of formula weights, D. Number of atoms. Complete the following. The sum of mole fractions of all the components present in the solution is always, the options are A1, B2, C3, D4. Identify the term generally used to express the concentration of atmospheric pollutants in cities. The options are A. Normality, B. Molarity, C. Formality, D. Parts per million. Let's have a quick recap. A solution is a homogeneous mixture which is composed of solute and solvent. The amount of substance present in a given volume of a solution is also expressed in other concentration terms such as parts per million, molarity, molality, normality. Molality is the number of moles of solute dissolved per 1000 grams or 1 kilogram of the solvent.